In this video and the next, we're going to cover arrays, and this corresponds with Chapter 7 and 8 of the textbook. Chapter 7 gives you an introduction to arrays and focuses on single-dimensional arrays, and in Chapter 8 we talk about multi-dimensional arrays. So in this video I'm going to focus my attention on Chapter 7, and in the next I'll focus my attention on Chapter 8. And in terms of the examples, from the textbook, you can see we have a number of examples from Chapter 7, and I'm going to focus a lot of my attention on this one in particular, Analyze Numbers, and then in Chapter 8. And I'll also be giving you a couple of my own examples just to kind of give a little more illustration. So if you took the Python class for your introductory class, you had something somewhat similar to an array, but with very important differences, called a list. And like an array, a list was indexable, but in Python, there's no such thing as an array specifically in Python in the same way that you have it in Java. Part of the reason for that is, remember, there's no such thing as primitive data, and you can have an array that contains primitive data. But another thing I might say about it is that an array is, while it's simple to work with, is much less flexible than a list. With a list, you can actually dynamically insert and delete entire elements from the list. You can append to the list, that sort of thing. And you cannot do that with an array. Now, in Java, there are lists, and maybe we'll even look at them. These are much more complex to work with than an array. So we're going to focus our attention on something that's simple, kind of like a Python list, but not exactly like a Python list. And as you can see in this slide, what is an array? An array is a data structure. When we talk about a data structure, we're talking about something that's not just a single piece of data, like a variable that's an int. That's often called a scalar data item, which means S-C-A-L-A-R. That means a single data item. But an array is not a single data item. An array can have multiple elements to it. And so it's a collection. So when we talk about data structures, we're typically talking about something that has multiple pieces to it. So this is a collection of, notice this, the type of data that has to be in this collection has to be the same types. Again, here's another distinction between that and Python lists. In Python lists, I could have put anything in elements of that list. But with an array, all of the elements have to be of the same basic data type. And Java treats them as objects. And so that means that unlike the primitive data types that we have looked at, integers and floats and doubles and whatnot, a variable that is an array is actually pointing to something, data, on what's called the heap, and we'll look at that. So it's not a value variable, it is a reference variable, and we'll make that distinction in this video. We have individual elements, and they're indexable, and they're stored consecutively in memory. And here's how we can see that we are indexing to get this. So this is similar to what you experienced with Python, the indexing capabilities of it. So this slide is showing you kind of the things that you are doing when you are working with arrays. For example, this right here is showing declaring a variable that is an array, and this is an array of where each of the elements is a double. And notice how we know it's an array is because we had, after the data type, we put open bracket, close bracket. In Java, you could have put the open bracket, close bracket after the name of the variable too. It would have worked, but I think it's better practice to put it after the data type. So this is a double array, is what this is saying. So my list is supposed to be a reference to a double array. And then here is where we are actually creating the array itself, and we'll talk about that in more depth as well. Notice the new keyword. You're going to come across that new keyword already when you worked with scanners to get input from the user. So the new keyword, we are creating onto the heap an instance of a double array, in this case of size 10. So this is how we would declare the variable and instantiate the double array. And then here we're assigning what the new operator gives us, which is a reference to the location in memory where this has been created, into this variable called mylist. So what we have in mylist is not an array inside the variable, but rather a pointer to elsewhere in memory that contains that array. And here we have the variable, which is a reference. We're seeing this illustrated here. So here's the variable. It's called mylist. This could be a local variable in a method, for example. And it is a reference to the array, and each of those elements you can index using the indexing scheme. So that what's expected to be inside the brackets here is an integer value, and moreover, it's supposed to be an integer value between 0, which is the first element, and whatever the size is, minus 1, which would be the last element. So arrays have what you call zero-based indexing. The first element is 0, then 1, then 2, then 3. Same thing with Python lists. So as I said, you could do it this way, or you can do it that way. I think it's better this way myself, with the brackets after the data type rather than the brackets after the name. By the way, when you go to C#, as you will in 484, you have to put the brackets after the data type. The syntax won't allow you to put it after the name. At least it didn't up to the versions that I've been familiar with. So here again is this notion of instantiating something, creating an instance of something. So in this case, we're creating an instance of a whatever the data type is, array, and we know it's an array because we got the brackets here, and we're specifying when we do this, new, whatever the data type is, for example, double, or whatever the array size is, for example, 10, we are explicitly reserving in memory, and when I say in memory, I'm talking about in a location of memory called the heap, which is to be distinguished from another location of memory called the call stack or frame stack. We're putting into that location in memory, we're reserving enough space to hold 10 of these doubles. So if we're going to have 10 doubles, recall from the chapter 2 notes that a double is 64 bits or 8 bytes. And so that would be 80 bytes reserved in memory, specifically in this location of memory called the heap. And then how do we access that? How are we going to be able to access that? It's because this assignment operator, once the new keyword has taken effect, is going to assign the location of the object that had just been created to this variable mylist. And now mylist is going to be pointing at it. We'll see some illustrations of that. And of course, like most things, you can declare and instantiate in one fell swoop, as you can see we're doing here. So arrays have a property called length, and that comes in handy. So mylist, which had been created from the previous slides, is going to have mylist.length is going to be a value of 10. And here's an example of looping through an array. This is a very common use of loops, is to go through all of the elements of an array. And in this case, what's happening is that we're looping for however many elements there are in that array. And remember, we're starting with element number 0. So if it was 10 elements long, then we would want to be looping up until 9. So we'd want to quit before 10, and that's why I minus. And notice the use of the loop counter variable here for indexing. Very, very common thing. So here's one way to initialize an array is via a loop. But another way to do that syntactically is to just, rather than saying new mylist equals new double, and then in brackets, whatever the size is going to be, we could actually just say my list equals, and then the curly Q brace, and an end curly Q brace, and however many, in this case, double values you would like. So in other words, this particular statement is really equivalent to doing all of these statements. It's equivalent to declaring and instantiating and assigning, and it's also equivalent to assigning specific values into each of the elements. So you can get a little bit of a shortcut by doing it this way. Okay, so what we're going to do now is we're going to look at this AnalyzeNumbers program, and we'll dive into detail about that, but let me just run it first. So here it is. This is a class called AnalyzeNumbers, and basically what it's going to do is it's going to ask me to enter, first of all, how many numbers I want, and then it's going to ask me to enter each number. And then once I've entered all the numbers, it's going to calculate their average. And then after that, it's going to identify how many of those numbers were above the average. Let me run it for you. So how many items do I want? Let's say 5. And now here are the numbers. I got to enter them. So I have to enter 5 double numbers. And notice I could be doing it one line at a time if I want to. But I could also put them all on the same line if I want to. I'm going to go ahead and do that. 3.2, 6.5, 7.1, 9, and 5.5. Oops. 9 and 5.5. So here are my numbers, 3.2, 6.5, 7.1, 9, and although I'm entering that as an integer, it'll do the implicit type conversion for me. And then 5.5, and let's see what happens. And there it is. Here's our average, and here's how many elements were above the average. So the average was 6.26, and 6.5 was above the average, and 7.1 was above the average, and 9 was above the average. Now, you know, calculating the average, I didn't need an array for that. All I needed to do was to sum them and keep track of how many I was adding together and then divide the average by the count. But in order to know how many were above the average, I got to keep track of what those numbers were, because I don't know what the average is until kind of after the fact. And so the array is what's allowing me to keep all of those individual values kind of in memory. And then we'll kind of take a look and see what this is doing in the code specifically. So first of all, let's take a look at the line that's highlighted here. This is really doing a lot of things. It's declaring the variable called numbers. Now, declaring the variable doesn't mean you've created the array. I could declare a variable, double open bracket, close bracket, numbers, semicolon, and there we have a variable, but we don't have the array. It's the new double that is creating the array. And notice that in this case, n, this value n, was a number that the user entered. So the user is deciding how big the array is going to be. Then at this point, with the new double n, we are actually going to create and instantiate the array, and then the assignment operator here is assigning it into the reference variable. So this is something that we have to distinguish in Java, this notion of value versus reference variables. And in the old days of computing, almost everything was a value variable. And with Python, there is no such thing as a value variable. Everything is a reference. But in Java, it's got a kind of a mix of the two. So a value contains data. And we saw that there were 8 types of primitive data, right? There was the Boolean, and there was the char, and then there were some numeric types of various sizes. Everything else is going to be a reference variable, including, by the way, strings, and we'll get to strings later, and certainly arrays, which they contain a reference. And now we're starting to get to the point where we're ready to dive into these different locations of memory. One is called the frame stack, or sometimes called the call stack, or sometimes called the program stack. And this contains the local variables and the formal parameters of a method. And when I use the word formal parameter, I'm going to later distinguish between formal parameter and what's called actual parameter or argument. So we'll be getting into some of that terminology when we get to talking about methods. And then the other location of memory is the heap, and the heap is containing all objects and arrays. So the stack is going to have a frame for each method as it is in execution, and it will contain the local variables and parameters of that method. And the heap is going to contain objects and arrays. And whenever you see a new keyword, that means something's getting created on the heap. So let's kind of go through what's happening here. So by the time we got to here, we've already got variable n, and that has a 6 in it. Assume that the user said I wanted 6 of them. And we also have this sum that has been initialized to 0. If we look at the code again, sum had been initialized to 0. Even if we hadn't initialized it to 0, it would have started off as a 0. So let's see what happens with this line right here. The first step that takes place is the declaration of the variable. So now the variable has been created, and there's a location in the frame stack with that variable. Notice that what we have in the frame stack is the frame for the main method. And at this point, in this example, there's only going to be the one method. Later on, we're going to see lots of methods, and we're going to see stuff happening to that frame stack. But right now, these are all of the local data, and that includes args, which is this reference that's not really pointing anywhere. There's actually an example of the use of args in, I believe, in Chapter 7. And then n, which is what the user had, when the user had entered a value, that went into there, and then sum. And now finally, because of this part right here, we have numbers. And then, before we can assign anything, remember, what's to the right of this assignment operator? That's an expression. Always, 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 to the right of an assignment operator is an expression. What this expression is going to give us is a reference to what? To something that's going to be created. And now we can see that we're creating the array is on the heap, and again, we're assuming that the user had entered 6, and it has 0, 1, 2, 3, 4, and 5. And then finally the assignment takes place. So when the assignment takes place, that means this variable that is in mains frame on the stack is pointing at that particular array, which is located on the heap. So that's what took place in this one statement. So now let's go further. And we had entered some numbers, let's say. So the user is prompted to enter some numbers. And notice we got a loop going on here. And we're saying input.next double. This is a scanner. Input's a scanner. Where's that? Input is a scanner, which, by the way, notice that the scanner was also created using the new keyword. You've used scanners by now. So scanner is an object. That object is located on the heap. So we're looping and putting values in here. Let's take a little bit closer look at this. So here's our loop. So we're dropping into the loop from above at this point. This is what we have here. And notice the use of the loop control variable, this loop counter, for indexing into the array. So the first time of the loop, we're going to element number 0. Second time, element number 1. Third time, element number 2. And you can see that as I is incrementing, values are being put into here. So at that point, we have all these values. At some point, the loop counter variable is going to reach n, which was 6. And this test is going to fail. And so we're done with the loop. And notice also that in this loop we were also summing. And then finally, we're able to calculate the average. And then at this point is when we can loop again and check to see which of those numbers are above the average. We wouldn't have been able to do that if we didn't have them stored in an array. And that's why we're able to say how many elements are above the average. So to illustrate this, I've put breakpoints at a few spots in the code. And let's debug it and see what we come up with. And first it's going to ask me to enter some items. We haven't reached any breakpoint yet because it's waiting here. It's right at this print, and basically it's waiting right here. As a matter of fact, let's say I want 4 items. And now if I look at the variables, what do we got? We have n has 4 in it. There's our args. By the way, input. What's input? Input is a scanner. And you know, scanners have a lot of stuff going on. If I expand on input, look at all of these things. This is all stuff that's happening and being used behind the scenes. We don't have to worry about the details of what the scanner does or how the scanner does it, but there is stuff going on. And so here we are about to instantiate this numbers. We haven't even declared it. You don't see the variable there. And then it's going to ask us to enter the numbers, and we're going to have to enter numbers. Maybe I'll put a breakpoint here at the print too, so we can see what the variable is going to have in it. So here's n. It's a 4. Let me go ahead to the next. And so here we have numbers, and you'll notice that numbers has 4 doubles, and they're initialized at 0. I should let you know that if these are primitive data types and they have their numeric data types, they're typically going to be initialized at 0, even though I didn't have it explicitly showing in the slide there. So it's initialized at 0. And now it's going to ask me to enter a number, and then it's going to loop each time, and I'm going to enter a number, and it's going to put it into each subsequent element of the array. So let's see that happen. So I'll go to the next breakpoint, and this next breakpoint is in the loop after I've entered a number. So let me go ahead and hit enter, and I have to go to my output. It's asked me to enter the numbers. As a matter of fact, let me do the same sort of thing I did before. I'll just enter all of them. 3.2, 4.4, 8.33, 10. Yeah, make it 1. Okay? And let's see what's going to happen now. I'm going to hit enter. And there I am, my first time in the loop. And if I look at my variables now, you'll notice that a 3.2 has been put in element number 0. If I hover over numbers, I can also see a little tooltip come up here. And if I wanted to, I could just expand on that and I'd see the same thing in here. That's a nice thing about these debuggers. And so I'll just kind of go through that process, and you'll see each of those are being entered, as you can see. And then finally, we're at this point. So sum, 16.93 divided by n, which is 4. Now, although n is an integer, sum is a double, so your result is going to be a double. And then that's going to be put into this average here. Maybe I'll put a breakpoint right here. And let's go to the next line. And there we have average. Now average now has this. And then we're at this point where we're about to create this count variable, but as you can see, it hasn't yet been created. And as we go, we'll find every number that's above the average. Well, which numbers are going to be above the average? What was the average? 4.2. And so 4.4 is going to be above it, and 8.33 is going to be above it. And so we can see now I is 1. So when I was 0, it didn't match, but when I was 1, it did. And then again, I is 2, it did, as you can see. And then finally, I think that will be the end of it. And finally, we've got to that point right here. And how many were above the average was 2. And that takes us to the end. So hopefully that gives you a little bit of an idea of how arrays work and how you can look at the contents of arrays in the debugger. Now, Chapter 7 has a bunch of other examples too, but most of these examples are making use of methods, and we haven't yet talked about methods yet, so we will come back to some stuff from Chapter 7 after we've talked about methods. But the important one that I wanted to really get a flavor for was the AnalyzeNumbers one. Now, one other concept that I want you to get a feel for, and you will be making use of this in an upcoming assignment, is the use of parallel arrays, where basically you might have more than one array, and the corresponding element of each array refers to kind of the same thing. So in this case, we're seeing that here's an array of strings of majors, and this here we have accounting, and there's how many accounting majors are there? 150. How many finance majors? 300. How many CIS majors? 120. How many marketing? 250. How many management? 500. And when you have parallel arrays, the size of each array, the length of each array has to be the same, but you can have different data, and that way you can kind of be keeping track of different properties, if you will, of the same kind of entity. That's one way of doing it. It's not the only way of doing it, but it's a useful thing to learn. And so I have an example. This is not an example from the textbook, but I've provided for you a folder, and I'm going to go ahead and go to there in Canvas and show it to you. So in the modules and in the code examples, you'll see, of course, this Liang 11e samples. I've been going through a lot of those examples, but here we have a few others that we'll be looking at through the semester. I might even add some more. And what I want to look at right now is this arrays, so let me pull it up. And I'm going to take this folder, I'm going to copy it from the zip file. In my Liang 11e samples, this is the project folder. And in the source folder, which remember has all of these packages, I'm just going to put that folder right in there along with these other ones. And here now I have a folder called arrays, which basically now that's going to be a package as far as NetBeans is concerned. I'm going to double click on it and you see a couple of examples, and we're going to look at this parallel array example. And in NetBeans, lo and behold, there's arrays. So I'm going to pull it up. I'm going to pull up parallel arrays. And here it is, these parallel arrays. Let me run it. And here's the output, as you would expect. Notice the use of the loop counter variable. Maybe I'll make this a little bit bigger. Let me go to Tools and Options and the fonts and colors. Let's make this 18 instead of 14. And now you can see it a little bit bigger. And so notice again the use of the loop counter variable for indexing into these parallel arrays at the same position, and also for printing the number out. I printed number 1, 2, 3, 4, 5, so hence I'm using I plus 1 here. In this case, the plus here was an addition, and then after we put a concatenation here, after we got a string here with a plus, that's when we were concatenated, and it actually converted this number into a string for display. All of that was done kind of automatically. And if I want to just put a breakpoint here just to illustrate what these look like, let me put a breakpoint. I'm going to go ahead and debug. And here we are. Let's take a look at students. And students is an array of integers. Let's take a look at majors. Majors is an array of strings, as you can see. And we'll talk more about strings later and some of the nuances of strings.